prove that a function with the following properties does not exist. We want to show that a function that its partial derivative with respect to x equals x plus 4y, and its partial derivative with respect to y equals 5x minus 2y. Such function does not exist. So we don't have any function that its partial derivative with respect to x would be this, and its partial derivative with respect to y would be that. I will show you here two methods for solving this question to show that such function does not exist. The first method is based on the Clairaut's theorem. What was Clairaut's theorem? Let me remind you. Based on the Clairaut's theorem, we know that fxy, the mixed partial derivative of f with respect to x, then y, it should be equal to partial derivative of f with respect to y, then x. The order of differentiation does not matter. And mixed partial derivatives are equal if the mixed partial derivatives are continuous. We know that fx is this. So if fx is x plus 4y, what is fxy? What is partial derivative of this with respect to y? Partial derivative of x plus 4y with respect to y is only 4. Because the derivative of x is 0 with respect to y, and the derivative of 4y with respect to y is 4. Fy is given 5x minus 2y. From this fyx, partial derivative of fy with respect to x is 5. But based on the Clairaut's theorem, we expect that fxy be equal to fyx. But as you can see, these two values are different. So these are not equal. So this means that such function does not exist. Because if a function with this property exists, then these two mixed partial derivatives should be equal. And because they are not equal, it means that such function cannot exist. This is one method for solving this question. There is another method, but that we can show that such function does not exist. Again, we start with this. The partial derivative of f with respect to x is x plus 4y. If the partial derivative of f with respect to x is this, with integration of f with respect to x, we can find the original of f. Because the derivative of f with respect to x is x plus 4y. So, what type of function is that its partial derivative with respect to x is this? For finding that, we take integral with respect to x. We do the opposite. Integral of x is x to the 2 over 2. Integral of 4y, attention, we are taking integral with respect to x. And because we take integral with respect to x, 4y is like a constant, like 10. What is integral of 10 with respect to x? 10x. What is integral of 4y with respect to x? 4yx. But we know that always when we take integral, at the end we have to add a constant, a c. But here the story is a little different. We had a function here. We took its derivative with respect to x, we got this. This constant is not necessarily a constant. It can be a function of y. Because suppose we had something like 10y to the 3 here. If we take the derivative of this with respect to x, at the answer, we cannot see anything from that. Because its derivative with respect to x is 0. So, here, we should not just add a constant at the end for f. We have to suppose that maybe we had a function in terms of y here, g of y. This is g. So we can have a function in terms of y at the end. Now, if we take the derivative of this with respect to y, we expect to get this. If we take the derivative of this with respect to y, so what is the derivative of this with respect to y? This is f What is the derivative of that with respect to y? The derivative of x to the 2 over 2 with respect to y is 0. The derivative of 4yx with respect to y is just 4x. And the derivative of gy is g prime y. Now compare this answer with this expression. G prime y can be this, because it's in terms of y, it can be that. But 4x here we have, but here is 5x. So this cannot be equal to that, because it's x, but this is 4x, but that is 5x. So this means that this is a contradiction, because we took the derivative of f with respect to y, we got a different answer than the answer that we expected to get. Fy, partial derivative of f with respect to y, in the question is given 5x minus something, but this is 4x minus plus something. So this is a contradiction, and this is another method to show that such function f cannot exist.